Hi guys, welcome to another episode of building the modern data stack from scratch. And in this episode, we are going to be looking at building dashboard preset cloud, which is a managed Apache Superset. My name is Adedu Sonny. I know I've not mentioned my name probably from the beginning of this series. My name is Adedu Sonny, and I'm a data professional, and I'm into data engineering, data analytics engineering, and the likes. So, in this episode, as I said, we're going to be focusing on building our dashboard in Preset Cloud. So, without further ado, let's quickly get into it. So, I think first thing I want to put to our notice is that there's a change that was done on our DBD models. So, I'm just going to reiterate that before we go into probably discussing the nitty-gritties of building a dashboard. So first of all, let me show uh, let me show our repo. So here we have our repo, and if you notice in our math layer, there is an additional model called Jaffle OBT. And the reason we have this model is because we want to because Pixel Cloud leverages your table and probably you writing SQL to create a virtual table on Preset Cloud. So unlike Tableau and Power BI, whereby you just connect the logical model between tables, but in this case, since we're going to be leveraging these several dimensions and fact table to create our our dashboard, and there's no ideal way we can actually connect, create a logical model and create a dashboard of Excel cloud. So we have to like create a a big table that joins all those tables into a singular table that we can use to build our dashboard. So that leads us to creating this Jaffle OBT, and this is the model that we use to create that. So I'm going to like run through some of the things that why we did what we did here, and show you in a bit. So this change is on the GitHub repo, so you can go in there. It's on mds-dev branch, so you can check for this model if you want to replicate it on your end. So before I come back and probably do some justice to how we came about this table, I just want to show you uh, the dimensional modeling behind it. So I'm going to preview something for you guys now. So here we discuss created some dimensional modeling and how we connect those tables together. So let me quickly show you. Let me take this. So here, if you look at this image on paper, I created like how those tables connect together. So we typically have like I think 4 dimensions and one fact. So customers, we have dim customers, we have dim products, we have dim stores, we have dim supplies. That's 4 dimensions already. Then we have like orders and items. These orders and items is the one that will connect together to form fact orders table, right? So having to like simplify from the base tables. Remember, our customer table has a column called ID, which uniquely identify each customer and is the primary key. So we can take note of that. Our product table also have like an ID called SKU, which uniquely identify each product. Our store table has ID, uh, which uniquely identify each store. Then for our orders and the items table, we merging these orders and items table, we have the fact orders table. So which combines the order ID on the orders table with the order ID on the items table. But before the combination, ideally, the ID on the orders table is the one that uniquely identifies the orders table, and the item ID, this is like the item ID on the items table, that breaks down each line item for each order, right? So on the orders table, the order ID is unique. But by the time you combine the two together, that is the orders table and the items table, which gives us fact orders, as you can see here, which gives us fact orders, then it has to be the combination of both order ID and item ID that will give us our unique ID. So coming to how we connect the dots together. So let's assume we are going to assume that this is the dim customer, and the dim customer table has the ID which uniquely identifies it. And because on the fact orders table, which is the combination of the orders and the items table, we have customer ID. So we can join customer to the fact orders table, and it's a one-to-many relationship. And why is that? Because on the customer table, the customer ID is unique to the customer table. So you cannot only have one ID attached to a particular customer. But on the other hand, on the fact orders table, customer ID can be repeated because a customer can get an order on a multiple occasions. So the customer ID is going to be repetitive in the fact orders table. So that's one to many. Now on the stores table, we have what we call the store ID, and on the fact orders table, there is a store ID there too. So that also is a one to many relationship because store ID on the store table is unique, but store ID on the fact orders table is not unique. Now for the products table, the product ID there is unique, which is the SKU, but on the fact orders table, the product there is not going to be unique because the product is going to be ordered as many times as possible, right? So that's a one to many relationship. So we can join product table with the fact orders table. Now the trick, the one that is tricky there is the supplies table, because the supplies table has what we call the supply ID and this and the and what we call SKU. Now this ID here is not even unique because uh a supply can be I want to use the supply. A supply can be supplying multiple products. For instance, let's say Maggi is a supply, or salt is a supply. Salt can be used for preparing different, maybe jaffu or something, or let's say sugar can be used to prepare different jaffus. It can be used in different jaffus or different products in this case. So it's not unique. Also, since since that is the case, SKU2 is not unique on this side because another supply can also be used on another product or another jaffu. So these two are not unique. So there's no way we can there's no way this supply can connect directly to all these other tables without having duplicate. So there's a problem here. However, product can connect with supply easily because on the product table, product ID is unique. But by the time we combine these two together, that is product and supply, uh, then the product ID is going to be duplicated. So at that point, there's no if the product ID is duplicated, there is no way it can connect to other tables again. So the supply table is just hanging there. However, because we might want to like identify the cost of production of those jaffles, we created I intentionally created what we call SKU cost, because on the supplies table, this there is a cost attached to uh the supplies used to produce a particular product. So by the time we add all the supplies used for a particular product and aggregate it, we can know the cost of producing a particular product or jaffle in this case. So that table we call what we call SKU cost, right? So that will give us the cost of produce of producing each jaffle or each product in this case. So with that, we can now connect what we call SKU cost with product, which is going to be one to one here, because you have aggregated the supply on the product ID level. So you can join together with this. So that will now take us back to the model that we created, which is jaffle OBT. So let me quickly go there. So here at the top level here, that is what I'm talking about as regards SKU cost. So this is the query that is used to generate SKU cost. So we have the product key, then we sum the cost at product key level, which is the product ID. So with that, you can get the cost of producing each of the jaffle. Then here we are now putting all the tables together by joining them. So first of all, select customers and select the attributes that we need from the customers table. Then join it with the fact orders table. So we are doing a left join here because we want to select all the customers, right? And then join on customer key. Then we want to join with the dim stores on the store key attribute. But here we are doing a full join. And right, because we cannot do a left join, because if we do a left join, it's going to ignore some stores that do not have an order, that probably a customer did not so we need everything from both sides. Also on the product, when joining the product table. So then at the final layer, which is this product cost that we generated here, we then do a left join on this product cost table on the product key. So that gives us our jaffle OBT table. All right, so having said that, let's now proceed to talking about the dashboard. However, before we do that, it's important that before you start building your dashboard, you should first of all brainstorm on, okay, what are the things that need to go into the dashboard? How do we want to I can pass some useful analytics to the stakeholders in order to make business decisions. So you think about the metrics that you want to dish out and how you want to organize it. So it's important that so we call this creating like a wireframe for your dashboard. So it's important that you create a wireframe for your dashboard before actually building the dashboard. So when you're creating a wireframe, definitely you have thought about the metrics that you want to dish out and create a wireframe like, okay, this is how the dashboard is going to look like, and these are the filters I want to use, and blah 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 blah. And after you've done that, you want to like engage the stakeholders. The stakeholders in this case are those people that are going to be consuming the dashboard to make business decisions. You want to meet with them that, okay, this is what I intend to create for, probably there's a request already. So this is what I intend to create. This is what it's going to look like. From there, they can then talk about, okay, maybe you should remove something from it, or you should add something, or you should do that, because you don't want to go ahead and build a dashboard and they will tell you this is not what they want, or they don't want it like this, they want you to remove this. So it's going to save you a lot of back and forth and stress when you are delivering your dashboard. So having said that, so before I started doing the dashboard, I had to create like take some time to like think about my into different sections. So let me quickly show that to you before I go into presets cloud itself. So let me show this. So I'm going to show, so this is the modeling part. I've showed this before. So let me go here. Yeah. So first I said I'm going to create like a customer analytics tab. So in here I want to know how many customers uh, the business have: customers with highest order, customer with highest revenue, active customers, top 10 customers by order total, etc., etc. I want to have another. I decided I want to have another tab. So let me open that up. I want to have another tab called product analytics. How many product type, cheapest product, etc., etc. How many products per product type, top 10 products by volume, etc. So I have like four sections like that. So I have transaction analysis, I have these details penned down. Then I also have uh, store analysis. So I have all of this penned down before I started, creating a dashboard. So it's important because it's going to like give you some kind of direction on before you start creating your dashboard. It saves you the time to actually put those things together on your BI tool. In this case, which is Preset Cloud. So after I've been able to do this, then the next thing is to now go in there. Since we have our big table, then since you have this metrics penned down, then you can easily think if you needed to create like a separate table to answer these metrics, or you can get it directly from the big table, which is Jaffa BT that's already been created. So let's delve into Preset Cloud and just walk through the dashboard. All right. So uh so I'm going to take some time to like create the dashboard because we don't want uh to spend time, having to like do the dashboard while recording at the same time. It's going to take a lot of time. So I took some time to like create the dashboard. So I'm just going to do a walkthrough. So on the customer analysis side, we need to put this uh this metrics just as I've shown before. So in order to do this, I had to create a separate metric table. So I had to create a virtual table in order to do this. So majority of the things that goes in here was gotten from the virtual table that was created. So I'm going to show that quickly. I'm going to run through that. So here on data, so you have data sets here. You see I have some virtual tables. So I'm going to filter by the owner. So I'm going to select my name. So I created some metrics table. So I have customer metrics. This customer metrics serves for majority of what goes into the uh, customer tab in the customer analysis tab in this dashboard. So let's quickly go into virtual table and see. So this is the query by do a distance count of their order, then the sum of the order total. Then after that, I did some uh Windows function to get overall total of order in terms of revenue, then overall total in terms of volume. I needed this for a particular metric in order to I'm going to show you in a little bit. Now, you will see that I'm using Jinja in at the top of this query. As filter into this place so that whenever I apply a filter to the dashboard, it just does that within the query itself. You are going to get used to this after you've explore Pixel Cloud. So, but when you are trying to do this, you cannot do this directly when you are creating your data set, because I need to create this data set first, right? So if you want to create data sets, we cannot create data sets by applying this uh Jinja. So what you need to do is first of all, you need to create the data set without these Jinja codes. So what you do is that you first of all remove this Jinja code. You remove it. So when you want to create the data set, you copy the entire query without this Jinja code. Put it in your SQL lab here. So put it in your SQL lab here. Highlight and run the query. After you run the query, then you come in here, then you say save dataset. Then you give the name of the dataset. Right. So after you've done that, you should still not put this Jinja yet. Only put this Jinja when you have probably built your dashboard, then you have now gotten the stage where you want to add filter and stuff like that. So if you have now decided that okay, these are the filter that I want to go into the dashboard, then you can go ahead and then put these Jinja codes in here. So before the end of the session, I'm going to like walk through the logic in this Jinja. So this is the customer metrics table, and this is going to answer for majority of the charts in the dashboard. So this for customer metrics. So let's go back to the dashboard. So for total customers, we can get that from here. When we count the customer, right? Then for customer with highest volume, so what I did is that to get customer with highest volume, you just have to like filter for when the other volume is uh is equal to the overall volume. That way we can get customer with highest volume. So I can just open up the chart so that you can see. So I'm using a table for that chart there. Then we go to the charts. Under charts, uh what's the name of the chart? This top 10 customers. Let me filter by the owner. Let me filter by the data set. I think I can do that. So customer metrics. So customer with highest order. Yeah. So here I'm using a table to present this data, and I drag in customer name because I don't know the name of the customer. Then in the filter section, I'll use customer SQL using a where clause and say when the overall maximum order volume is equal to the order volume. So that will give me the customer that had the highest overall order volume. So similarly, to get for the highest revenue, I'll just use where the order total is same thing as the overall order value. So for total active customer, what is it is like, okay, how many customers have already purchased or placed an order, at least one order. So you have same figure here. Then here we have top 10 customer by order total. So with this, we want to know the top 10 customers that had highest order in descending order, in terms of value, in terms of monetary. Now for the second chart beside it, this is in terms of volume of order, number of orders by that customer, and I'm using a table to present these two, and I'm only selecting the top 10. So how do we do this? If I come here, top 10 customer by order total, so I'm using a table also to represent this. So I will aggregate, but you can typically present it as raw records because it's already aggregated. If you look at the data set itself, I think it's here, is already aggregated on customer level. So you can present it as raw table instead of aggregate. So now bring in the customer key, the customer name, then the order total. Then what I need to do, limit the row to 10 because I need the top 10, and I need to sort in descending. Right. So that's how we got that. Now, the next thing is monthly distribution of active customer. For this, we could not use the customer metrics table to do this, and because we need we need what we're trying to get here is the number of customers that place at least one order in each month. So the date attribute is needed in this case, and because in the data set for the customer metrics we didn't aggregate, we didn't use date to aggregate it, we aggregated at customer level, so we cannot use this. So I use the base table, which is the Jaffa OBT, to create this chart. So I just did the count the number of customers aggregated at date level. That is the ordered at date. Let me quickly go through that. Let me show you. So I'm using a Jaffa OBT. You have two of them. One is for the one is for an old connection, one is for the new connection that I'm using. So let me just, I think it's this one. Yeah, monthly distribution of monthly distribution of active customers. This is it. So I'm using the Jaffa OBT data. This is a physical data set, unlike the other ones like customer metrics. So I have to drag the ordered out to the x-axis. Then this I have to drag the customer key. Then yeah, I just name this as active customer. I'm using the customer key column, then doing a count distance, and filter. I filtered for when the other data is not null. This one is just a default filter here. There is nothing else. But if you want to customize your chart, depending if you want to change the color of the bar, this is the section where you can do it. If you want to make the bar to not be vertical, want it to be horizontal, you can switch it, etc, etc. So now that's on this. Now another thing is the customer loyalty metrics. For the customer loyalty metrics are not a separate virtual data set to have to be created, because the customer metrics table cannot answer this metrics. So in this in this chart, we needed to get some certain classes of customers. So active customers, retained customers, churned customers, returned customers. So I'm going to break this down for us. So active customers are those customers that purchased at least one order. Retained customer. So because I'm aggregating this on a monthly basis, so you have to this you have to picture this on a monthly basis. So now, so for instance, January, I'm counting, okay, how many customers are active for January. So in January 2017 year, active customers are 312. Now, retained customers, you have to see retained customers. When I say retained customers, each customer is considering prior month to current month. So meaning that if I'm considering January 2017 now, retained customer has to be speaking to December 2016. Okay, if we have 400 customers that were active in December 2016, how many of those 400 customers also perform transaction or also place at least an order in January 2017? So how many of those customers were we able to retain to the next month? So that is what we think customers here are. So if you look at this retained customer figure, is 274. It means that in December 2016, we were able to retain 274 customers from December 2016. in January 2017. That is that. Now, churn customer means that how many of those customers in the previous month stop transacting in the current month. In this case, you have zero of them. In this case, you have zero of them. And return customers. Return customer means that these people did not transact in the previous month, and they they came back to uh to transact. Now, I didn't consider new customers here. You can adjust the query in order to cover for new customer. I was supposed to even cover for new customers, but I forgot totally. So this return customer might consider or might consist of both returned and new customer. New customer in the sense that these customers are just transacting for the first time in January 2017. That was their first transaction. So we only have 4 classes here. So let me quickly show you the query that was used to generate this. So now under dataset, I called it business analysis. This is it here. So business analysis, this is what it looks like. So at the top level is we are considering for each customer when was the first time they transacted. Then don't mind this label, current last 6 or previous last 6. Don't really mind it. So what we're trying to do is that because you are comparing the current to the previous, so that is typically what this and this one is doing. So comparing the current and the previous. So in here we are now considering on a monthly basis. At customer level, we are doing okay. The last time the customer transacted, and also previous month we did the same thing. Then we now join those two information together, or 3, because we want to use this first part. Most of we are comparing this and this, and the reason we are even using this in the first place to identify new, but I didn't consider it. Uh, 3 queries. We now join it to get our classes, which are retained customers. I think I have active customers, return customers. Oh, I have new customers into consideration. I didn't put it into the class there, so it also covers new customers. So that is on that. So most of this query, or probably all of them, I'm going to make provision for them and put it in of this video. You should find the repo to this query in order to help you replicate the same. All right. So the next one is cohort analysis. This is more like interesting query. Can be complicated, but then it's interesting. So what is this trying to do? So a separate query was also used to answer this. A separate query was also used to answer this. So all I'm trying to do here is that we consider a base month. So we consider a base month. Okay. For instance, this is January 2017. In January 2017, how many active customers do you have? 312. Now, out of this 312, how many were we able to carry over to the next month, which is February 2012. We were able to carry over 307. Same thing, how many were able to carry over to uh February February 2017. Out of these 3 months, we were able to carry over 309. Likewise, 3 months after, how many were able to carry over, and 6 months after, that way. Also, in February 2017, we had 334 active customers. How many of these 334 were able to carry over to the next month, which is March 2017, etc., etc. That is what this analysis is about. So it's more like help us to identify uh, our loyalty band for a period of time. So how are we able to like keep our customer engaged? How are we able to keep our customer engaged over a period of time? So we also have like a different uh, query that was able to help us to answer this, which is this cohort analysis table. So I won't have the time to talk through all of these uh, data set. So that is on the customer analysis. Then for product analysis, you have these metrics. So you have total product, you have 10 total product, cheapest product. We're able to use to get the cheapest product. The same logic for that was used to get like customer with highest revenue and stuff like that was also used here, also for most expensive product and best selling product. You will understand what I'm talking about from the query. Top 10 products by name, aggregate. This was generated from the product metrics table. So able to get the top 10 products, we just limit the number of rows, just as I've explained before. Also top products by volume, and then top products by profit. Profit in this case, if we look at the query, you see how we analyze profit. And because we've created a cost attribute, from our Java OBT, we're able to we'll just subtract uh the selling price from the cost price to get our profit. So there we can then track profit of the business. Yeah, transaction analysis, on the transaction analysis side of things, have the total orders, total revenue, and the total profit. Then let me just speak to this chart. Uh, I think I should speak to this chart, but before, let me just go through this other chart. So you have monthly distribution of order value and monthly distribution of order volumes. Just like select the ordered at table and aggregate the order total and do a count of the order volume to get this. Then the monthly distribution by profit, similarly, just your order total, your ordered at table attribute. Then you sum your profit column in order to get this chart. So let's quickly speak to this chart. So this is a big number chart with a trend line. It's different from this other two here. So what it's doing is that, okay, this is the total profit for the entire calendar year, but here is showing comparison of profit to the previous month. So the current month here is the profit here is 3.89, and so what is saying here is that there is a 9.1% growth compared to the previous month. So compared to this is 9.1% growth. All right. So let me show you the chart and how we're able to like implement this total profit charts. Total profit chart. I think total profit chart. Uh, total profit. I think this is it. Yeah. Big number with trend line. So that, no, select your we need this date attributes, for comparison sake. So time gain is month, because we want to compare the month. Allocation method is sum, because we want to get the entire profit in this case. What's the metric that we are summing is the profit. This filter is, in my select open at something, just change to other that. Now comparison, I'm comparing just like the previous month, just 1 month before. So select comparison suffix. So this one, month on month, I just put MOM. This is, you type this one just by yourself. So I think that's the only customization. All right. So the last thing is was store analysis. Store analysis, there's not much, nothing really much here. Total store is 6, youngest store, oldest store. In order to get this, you use the opened at attribute from the query, you understand, using it from the store metric dataset. Most selling store, that is, has to do with uh the number of total orders, the order value. Then top 5 store by order value and top 5 store by order volume. And because I've already applied a filter here, that's why only Brooklyn is showing here. So I want to remove this legend. Then top 5 stores by profits, only Brooklyn is also showing here. So let me remove this legend. I don't like this legend. I just go to customize, uncheck this show legend, and save. Go back to dashboard. So that is on that. So for filter, in order to add filter, you just have to, I just minimize the filter thing. Just have to come here and click this and go to this settings tab, then click on add or edit filter. So here, that is when you add filter to your dashboard. The first thing is, I use the date filter. Yeah, in this case, I selected the time range. Date filter, you will have selected the column that, that you want to use as filter. So I'm using it here. Then I'm using product name as filter also. So you might be wondering that how do we excuse me, how did you add? If you scroll, you see the option add filter. So then let me click on it, add filter. So to create an untitled filter here, then you put filter value. Is it a value for this product name? Filter type store values in this case. But let's say I want to put filters, I'll select time range. Then filter name, I'll put date filter. So because the date filter, it will use a calendar date. Whereas in this case, the filter name, which data do I want to select data from? You put select data set, then long that you want to use. So then if all you want, and you can, if your filter has default values or something, and if that filter if the filter value is required, you can put it and stuff like that. So I'm gonna delete this part. So if you look at if you look at those filters that I added, I'm not using, for instance, now metrics. I'm using the base table that we are using it throughout, because even customer metrics, product metrics are all created from the graph. So instead of having to like say, okay, I want to set up product virtual table, just go ahead and pick it up from the base table itself, which is the JAFOBT. So you should do that instead. So then you save, cancel. So okay, one thing I want to also mention, let's go back to filter, add or edit filter, is what we call the scoping. Filter scoping, you can which of your uh each of your tab, each of your dashboard, should your filter affect. For instance, this is a date filter now. 4 tabs: customer analysis, product analysis, transaction analysis, store analysis. So if you look at customer analysis now, that's not affect, so it should affect this other chart. For transaction analysis, and this is that it is checked. This all. So on this should only affect so chart. So that is important. Another thing I want to mention is your customization of your dashboard. So look at this. This dashboard is plain. There is no color and all of those things. If you want to do customization on your dashboard, I think I mentioned before, that's you have to use CSS. I didn't do this. I intentionally did not include customization for it, but I'm going to probably just give you guys like a base customization configuration file, and share it with you guys, and you can play around it. But for the purpose of this session, I'm not going to do that. So when you go to edit and click on these 3 dots, you see edit CSS. You blurring or stuff like that to go to. So I'm going to provide something that you can work with and compare around. So having said that, so after you've created your dashboard, you because you're using free account, right? You invite users. You can invite users to your workspace. So here, I'm the only user here. You can invite users. So 4 members left. It means that you can invite another 4 members, making 5. So you can only have 5 person. But one thing you should know, that anybody you invite, I think I mentioned it before, they will have admin permission, meaning that they can go ahead and delete your dashboard, either by mistake or intentionally. They can modify your dashboard. So you should take note of that, right? So can share add workspace members, or enter email address to add new members preset. Share that with workspace or whatever. Create copy it to access the dashboard directly. So you can do that. So I think that is where I'm going to stop for today. So I'm going to share the query that was used to generate the data set that was used to like work on this dashboard. So quickly, let me show you guys the data set that was created. Abiodun Emmanuel. So apart from the JAFOBT, which is the base table that was created from DBT directly, we created one virtual data set, quote analysis, business analysis for the the charter speaks to active, churn, and the rest, customer metrics, product metrics, and store metrics. That makes 1, 2, 3, 4, 5 virtual additional virtual data set that was created in order to to build this dashboard. So that will be it for the business intelligence side of things. So this is going to be our more our last episode, but there's going to be an extra additional episode for tips and best practices for some of the things that we've talked about, right? And and I'm going to probably mention if there are additional materials or additional things that I need to provide for everybody that has been following this series from the onset, and that to reproduce what we've done. That is what I'm going to mention it. Thank you guys for staying tuned up until this time. I will see you guys once again. You guys should ensure to like the videos, share with friends and families, your colleagues at work, and ensure that you hit the subscribe button. Thank you very much for your time. See you another time. Bye.